Alright, we're going to talk about graphing sine and cosine in this video. So the first thing you need to know is a little bit of terminology. So this is actually a graph of sine. The graph of cosine looks basically the same. Definitely has the same properties, so let's look at those properties. The first one, if you look at this, there's something that we call a period, so that's how long it takes to repeat itself. If you look at the graph, it's basically just repeating itself over and over. The natural period of sine and cosine is 2 pi, and we're going to mess around with that, but so the period is how long it takes to repeat itself. If you notice, within one period, we get 4 kind of distinct things that happen. Each of those happens one increment apart, and an increment, therefore, is 1/4 of the period. The next thing that you might notice is, I'm going to call that the starting point. I could have easily chosen that point all the way on the left there. Actually, I could have chosen any point, and you just have to keep repeating the pattern, and there's obviously a pattern, right? So we have something called an amplitude. An amplitude is how far away from kind of the central axis of the graph can get. So you start at that axis and you go up to a maximum. How far apart those are is the amplitude, or you can start at the axis and go to a minimum, and how far apart those are is the amplitude. Or of course you could go from the maximum to the minimum and then take half that distance. Either way, you're going to get the amplitude, which is a positive number. It's an absolute value because it's a distance. And then finally, well, not finally, but we have something called the sinusoidal axis. That's kind of where the graph is hanging. I'm going to abbreviate that SA all the time. So in this case, that would be y equals 0. And the amplitude is measured from there. And if you look at the pattern, we have an intercept, a maximum, an intercept, a minimum, and an intercept, which I've just labeled. And we're going to use that to establish some patterns for these. So what I want to do now is go through graphing one. Well, actually, first we're going to figure out how to calculate everything. So we got these two general equations, y equals a sine of bx plus c, and then plus d on the outside, or y equals a cosine of bx plus c, and then plus d on the outside. So what does each thing give us? Well, to figure out the period of the graph, it's going to be 2 pi, the natural period, divided by b, that coefficient of x. To find the increment, that's going to be the period divided by 4. So first you calculate the period, you divide that by 4, that gives you your increment. To find the starting point for the graph, what you're going to do is take whatever's in parentheses, so bx plus c, and set it equal to 0, and then solve. So the starting point ends up being the opposite of c over b, but the easiest thing to do is just set up that really simple equation and solve it. You want to rewrite these two things so that they have the same denominator. So you're going to find a common denominator. That's going to help you with labeling things. Amplitude is just going to be the absolute value of a, so amplitude's always positive. The sinusoidal axis is actually just y equals d, so that one's really kind of the easiest to find. And then we also need to know the maximum. So the maximum is you're at the sinusoidal axis, and then you're going to add the absolute value of the amplitude. And then the minimum, you are at the sinusoidal axis, and you're going to subtract the absolute value of a, or the amplitude. So the next thing we need to know is some patterns. So there are really only 4 patterns, and I'm going to set them up in this table here. So if a is greater than 0, the pattern for sine is going to be intercept, maximum, intercept, minimum, intercept. If a is less than 0, what happens is the maximums and minimums switch. So it's intercept, minimum, intercept, maximum, intercept. Some people try to pronounce that. I don't. Cosine goes maximum, intercept, minimum, intercept, minimum, maximum, sorry. Oh, do that one more time. Maximum, intercept, minimum, intercept, maximum. You can't screw it up when you're graphing, but you can when you're talking. And then if a is negative, we get this switch again. So minimum, intercept, maximum, intercept, minimum. Alright, so now I'm going to graph 2 of them and see what we can do. So first thing you do is you collect all that information. So the period is 2 pi over b, or in this case 2 pi over 4, which is pi over 2. The increment is the period divided by 4, so that's going to be pi over 2 over 4, which is just pi over 8. Starting point, I take whatever's in parentheses, which is 4x plus pi, set it equal to 0. I'm going to solve and get x equals negative pi over 4. But remember, you want to write this and the increment in the same denominator, so that's going to be negative 2 pi over 8. And then the sinusoidal axis is just y equals d, so y equals 2. The maximum is the sinusoidal axis and then plus the amplitude, so that gives us 5. The minimum is the sinusoidal axis minus the amplitude, which gives us -1. And then since a is less than 0 in this case, the pattern for sine is going to be intercept, minimum, intercept, maximum, intercept. So you really got to memorize those. Next thing I do is I kind of set up my axes here. So I'm going to put the starting point in the dead center. I do that kind of no matter what the starting point is. And then what you can do is you can just count off by the increment. So I'm adding pi over 8 each time. And you can see I skipped it at 0, so it was -2 pi over 8, -pi over 8, 0 pi over 8, which is just 0, and then pi over 8 and 2 pi over 8. And I'm going to go in the opposite direction. So that's why we want them to have the same denominator. It makes it super easy to do this. You can reduce those fractions if you want, but I don't. I'm going to put in my y-axis. Make sure you count it off. So counting 2 boxes per. When I graph these, I always do 2 boxes in between increments. And then the y-axis is a little more vague, but along the x-axis, it's starting point in the dead center, 2 boxes per increment. It gives you a really nice graph every time. So once you have your axes set up, you dot in the sinusoidal axis, which in this case is at y equals 2. And now at the starting point, we start the pattern. So at the starting point, it's going to be an intercept. And then I'm going to move over an increment to -pi over 8, and I'm going to go down to a minimum, put a point, and then you go over an increment and to an intercept, over an increment to a maximum, over an increment back to an intercept. So that's the pattern. And then going backwards, I'm back at the starting point. So to go backwards, I'm going to go from intercept to a maximum, then intercept, minimum, intercept, and now I put the graph through it. So you want the graph to be curvy. I mean, it's not an absolute value graph. It's a little harder the bigger the amplitude gets. And then just make sure you indicate little arrows at the end to show that it keeps going. So that's our graph of -3 sine of the quantity 4x plus pi and then plus 2. I'll do a cosine graph now. So I have y equals 2 cosine pi over 3x minus pi and then -1 on the outside. So I want to get all that information. Period is 2 pi over b, which is 2 pi over pi over 3, which is just 6 in this case. The increment is the period divided by 4, so that's just 3 over 2. The start is going to be, take whatever's in parentheses, set it equal to 0 and solve. So in this case it's 3, which we write with the same denominator as the increment. Sinusoidal axis is y equals -1. We need a maximum, which is the sinusoidal axis plus the amplitude, so that gives us 1. And then the minimum is the sinusoidal axis minus the amplitude, which takes us to -3. A is greater than 0 and it's cosine, so it's maximum, intercept, minimum, intercept, maximum. We're going to set up our x-axis, count off by increments again. So again, if 0 ends up one of the increments, I just put the y-axis there. If not, I don't really have a problem just putting the y-axis kind of where it goes. Or sometimes I just put the horizontal scale off to the side. It doesn't really make a difference. So I'm going to dot in the sinusoidal axis. And now at the starting point, I'm going to be at a maximum. So at the starting point, I'm going to be at +1. And then fill in the pattern. And then you can go through that. Nice smooth curve. And then go backwards. And really put some arrows at the end. There we go. And so that's about it. What would we skip in this? Well, I didn't graph 4 things, I only graphed 2, so I skipped a positive sine graph, which would have gone intercept, maximum, intercept, minimum, intercept. I skipped a negative cosine, which is minimum, intercept, maximum, intercept, minimum. I also skipped an ugly starting point, which I guess you might think of an ugly starting point as one where it's not really easy to get to 0. Everybody wants to put the y-axis in there in a perfect spot, but it might not happen. And if it doesn't happen, I would skip it until the very end, because otherwise you're going to want to put a point there. I don't know why. It's something psychological, but you should avoid that. Where do you go from here? You take what you learned about this and you learn how to graph cosecant and secant. That's really the ideal direction to go in. But anyway, it's kind of a long video, but I hope this was helpful. Good luck.